Okay, the first thing I want to do is finish up the discussion on partial fraction decomposition by going over one more example. We haven't done an example where one of the quadratic factors has an exponent. So this is the example where the integrand is 1 minus x plus 2x squared minus x cubed divided by x times x squared plus 1 squared. So the multiplicity of the factor of the quadratic factor in the denominator is 2. What's the degree of the denominator here? What's the degree of the denominator? 5, right? Which is bigger than 3. So it is a proper fraction. So what's the decomposition then? The decomposition will be for the linear factor x, because its multiplicity is 1. We are going to get only one fraction in the decomposition for that linear factor, and it will be a over x. For the quadratic factor x squared plus 1, because its multiplicity is 2, we are going to get two terms in the decomposition for that. And the two terms will be bx plus c over x squared plus 1 plus dx plus e over x squared plus 1 squared. And then, of course, I have to find a, b, c, d, and e. I'm not going to show you how to find those numbers right now, but if you find the values of a, b, c, d, and e, you will get the numbers 1. A is 1, b is negative 1, c is negative 1, d is 1, and e is 0. And if you plug them in, you get 1 over x, negative x minus 1 over x squared plus 1, plus x over x squared plus 1. Any questions so far? Okay, so what's the integral of 1 over x? What I have then is the integral of 1 over x plus minus. So the middle term that I have here, the middle term, I am breaking it into two fractions. So I'm going to get negative x over x squared plus 1, and I'm going to get negative 1 over x squared plus 1. So break this middle fraction into 2. So you're going to get negative x over x squared plus 1 and negative 1 over x squared plus 1. So that those two integrals in the middle, they are coming from the previous middle integral. And then I have the integral of x over x squared plus 1 squared. What's the integral of 1 over x? The integral of 1 over x is just ln of absolute x. What is the integral here? How would you calculate this? Yeah, notice that the derivative of the denominator is on the numerator, except for that 2. But if you take u to be the denominator, you can transform this integral into integral of half 1 over u du. And that's going to be half ln of u. And then you can say ln of x squared plus 1. Okay. This guy is, this integrand is the derivative of what? Inverse tangent. So this is inverse tangent. And the last one, you're going to do u substitution again. But this time you're going to get 1 over u squared. You're going to get 1 over u squared. And what's the integral of 1 over u squared? What's the integral of 1 over u squared? Negative 1 over u, right? 1 over u squared, not just u. So we're going to get ln of absolute x minus half ln of x squared plus 1 minus tangent inverse of x minus 1 over 2x squared plus 1 plus a c. Is everybody okay? Today, the next thing that I'm going to do is I'm going to go over some problems from section 7.5. Now, what is section 7.5? Is that so far we learned a lot of integral formulas, a couple of different integration methods, and 7.5 is where we'll be tested whether we know how to use them all. Okay, so in 7.5 you have a bunch of integral problems, and you just have to go over them. And you already know the techniques, you already know the formulas, you just have to evaluate them, okay? So there is no theory that I have to cover from them. There isn't any new information that I can give you to equip you with the skills to solve those problems, okay? You already know everything you need to know. So I have done a bunch of problems in the morning section, and I decided to do different problems here. So when I upload both videos, if you watch both of them, if you watch the one from the morning section, you're going to see new problems. You don't have to watch the ones from this section because you're already seeing it. Okay, so let's do that. Okay, so okay, so let me start. So this would be 7.5. Have we looked at the integral of tangent inverse here? How would you find the integral of tangent inverse? Yeah, so integration by parts. So if I want to use integration by parts here, there is only one choice. You have to take u to be tangent inverse of x, and you can pick dv to be dx. Dx means 1 times dx. Okay, dx means 1 times dx. And if I chose, should I be choosing dv to be tangent inverse? Well, that would be a dumb choice, because if you pick dv to be tangent inverse, right, you have to know the integral, right, to find v. Am I making sense? But that's what you're trying to find. You're trying to find the integral of tangent inverse. So if you pick dv to be tangent inverse dx, then you have to find v, but that's what you're actually trying to find. So that's not going to be a good choice here. Now, what is du? What's the derivative of 1 tangent inverse? What's the derivative of tangent inverse? 1 over 1 plus. And what is v then? Okay, integration by parts tells us what? It'll be u times v, right? Minus the integral of v du, right? So our integral would be, what is u times v? U times v is x times tangent inverse x, and then minus, we have the integral, and inside the integral you're going to multiply v and du, right? So v is x, v is x, and du is 1 over 1 plus x squared dx. I forgot to write dx here. I should put that. Okay, du is 1 over 1 plus x squared dx, and then I just have to find the integral there, right? What is the integral here? How would I calculate this? We just discussed it in a few seconds ago. You're going to do a substitution. You're going to take u to be 1 plus x squared This u has nothing to do with the previous u, right? This u is a completely different person, right? Brand new u, right? Yeah, exactly. So this is du is 2x dx, which would tell you that half du is what? Half du is dx. And so the second integral that I have there would be x tangent inverse x minus x dx together will become du, and then 1 over 1 plus x squared will become 1 over u, and x dx would be what? Half du, sorry, half du. And so this would be x tangent inverse of x minus a half integral of 1 over u du, which would be x tangent inverse x minus half ln of u in absolute value plus a c. Okay, one more line. X. Feel free to skip any of the steps here in the exam if you can. Ln, what was u? U was 1 plus x squared. Do I need to put absolute values? I don't need to put absolute values. I can just put parentheses. Any questions on what we just did? Any questions at all? Some of the integral problems in this section are it's a little bit tricky. You don't see right away how it's going to work out. Okay, many of them, and you just have to start doing something, and you'll see that it's not. They are not hard, but you have to start working on them and see how they are going to come out. Don't think you're going to know right away what to do. Okay. Let's do an example. This is, I think, problem number 73 in 7.5, but I might be off a little bit because the numbering that I have is from a previous version of the text. So I'm not going to say what number it is, but I'm pretty sure it is one of the problems. Okay, so what do I do here? My integrand is what? My integrand is 1 over x minus 2 times x squared plus 4. Proper? Okay, what would be the decomposition? Someone please tell me what's the decomposition. Okay, a over x minus 2 bx plus c. Okay, very good. Before you actually do this, you have to make sure that the quadratic that I have there is actually irreducible. But it is obvious it's irreducible, but you should always make sure of that. Now, I need to find a, b, and c. What should I do? If you have watched the videos, you know exactly what to do. Okay, multiply both sides by x minus 2 and x squared plus 4, right? So if you do that, on the left-hand side, all you get is 1. Okay, what do you get on the right-hand side when you multiply both sides by x minus 2, x squared plus 4? A times x squared plus 4, yes. Is everybody okay with that? And then I get bx plus c. Whoops. I get bx plus c, and that would be multiplied by, you agree? Multiply both sides by the denominator of the left-hand side, and you're going to end up with that. Is it right? Because you're going to multiply a divided by x minus 2 by x minus 2 times x squared plus 4, right? But you have an x minus 2 in the denominator, so it's going to cancel out. You're going to end with x squared plus 4 there. In any case, so now what we need to know is how we could solve for a, b, and c. Okay. Now, yeah. So right away, if you let me first of all do it in a different way. Okay. There's this solving for a, b, and c. I need you to know first of all the most general way of solving them. Why is it important to know the most general ways always? Just because you know there is one way that applies to every problem. But then there are tricks for each individual problem where you can evaluate ABC in a little bit quicker way. But the most general way, some time ago I saw someone in YouTube, some guy was talking about this, and he was, I think he's a teacher somewhere, but he was complaining why his teachers never showed him the quicker ways. And I think he should have known that you must know the general way, because the general ways are what you can apply to any problem, and you can write a general algorithm for any of these problems versus for individual problems what tricks you can apply. Am I making sense? So you actually should know that. So okay, so what's the general way? The general way is that you just multiply out everything and collect like terms. If you go back to your baby math courses, you have done that over and over and over again, right? You were asked to multiply out polynomials and collect like terms, right? Do they ring bell? And so I'm going to multiply out. On the right-hand side, if I multiply out everything, what's the largest power of x you can obtain? What's the largest? Okay, you can. I have all the confidence in you that you can multiply out everything here, collect the like terms. But I'm going to do it in a little bit differently. What's the largest power of x you can get? X squared, right? So I'm going to think about, okay, what would be the coefficient of x squared if I multiply out everything? Right? From the first term, I see that there's only one way of getting x squared, right? So the only way of getting x squared is a times x squared, right? So I get a. From the second term, the only way I'm going to get x squared is when I get an x term here and an x term here, right? So the only way I get an x squared from the second term is when I multiply bx and x. So that's going to give me a b. So I see that the coefficient of x squared has to be a plus b. Now, I want to know what should be the coefficient of x. Do I get any x term from the first? I don't get any x term from the first, right? Because it's a times 4, right? So how many ways can I get an x from the second term? Well, I get an x when I multiply c and x, and I also get an x when I multiply bx and negative 2, right? Is that right? So from the second term, there are two ways of getting x. One is when you multiply c and x, and the other is when you multiply negative 2 and b. So that tells you the coefficient here is c minus 2b. And what's left? The constant. So constant would be, you get 4a from the first. You get 4a from the first, and from the last you get negative 2c. Am I right? Okay. Now, this equality that I got, so remember at the beginning when I set up this equation, that equation holds true for any x. So the equation that I have here, 1 is equal to a plus b x squared plus c minus 2bx plus 4a minus ac. It's true for any x. In other words, I have two polynomials on two sides. And if they are the same, the coefficients must match. So what's the coefficient of x squared? What's the coefficient of x squared on the left? What's the coefficient of x squared on the left? 0. And on the left it is a plus b. What's the coefficient of x on the right? On the left it is 0. What's the constant on the right? 4a minus 2c. That's equals to 0. No, sorry. That's got to be 1. Is everybody okay? So all I did is matched the coefficients. A plus b, what is the coefficient of x squared here? X squared doesn't appear, but you can say that its coefficient is 0. What's the coefficient of x? What's the coefficient of x on the left hand side? Well, it doesn't appear, it means that its coefficient is 0. 0 times x. What's the constant? 1. Constant here is 4a minus 2c. So you got 3 equations, 3 unknowns, so you should be able to figure out what should be the values of a, b, and c. Am I making sense? Is everybody okay? All right. So now let's solve for a, b, and c. First of all, I am going to rewrite this as a plus. I'm going to put them in one order. So a plus b plus 0 times c equals to 0. I'm going to write this as 0 times a minus 2b plus c equals to 0. The second equation, I'm rewriting that. And this is not the only way you can do it. Of course, one of the trick you could do is that you can, from the second equation, you can say c is 2b, and then put that value in the third, and then you get 2 equations in a and b, and then you can solve for a and b. Okay? But let me do it in a little bit differently here. So this would be 4a plus 0b minus 2c equals to 0. Okay, so the first thing that I'm going to do is that I am going to make, was that? Oh, equals to 1, sorry. Equals to 1, thank you. What I'm going to do is I'm going to make all the coefficients of a 0 except for the first one. So the first one I'm going to keep as it is. Right now I'm not going to bother to write 0c again. If the coefficient of a in the second one is already 0, then I don't have to worry about that right now. Minus 2b plus c equals to 0. And the coefficient of a on the third one is 4. So what I'm going to do is I am going to multiply the first equation by negative 4. Okay, I'm going to multiply the first equation there by negative 4, and then I'm going to add it to the third one, and that's gonna get rid of that a term in the third one. You're okay with that? So multiply the first equation by negative 4. So I get negative 4a added to the third one, vanishes the coefficient of a, and then minus 4b plus 0b, that's going to be minus 4b. So I'm going to get minus 4b, and then you're going to multiply minus 4 times 0c, which would be 0c still. Add it to the third row, you get negative 2c still. And you're going to right hand side is 0, so negative 4 times 0 is still 0, 0 plus 1 is still 1. So I'm going to get that. Is everybody okay? Now I'm going to look at, so all the coefficients of A are 0 except for the first one. Now I look at the second two equations. I'm going to now annihilate the coefficient of B in the third row. So the way I'm going to do it is, well, you can imagine, I guess, what you should be doing. I'm going to write negative 2B plus C equals to 0. So what can I do to make the coefficient of B 0 in the third row? Well, I can multiply the second row by what? Negative 2. Multiply the second row by negative 2, right? And then add it to the third row. So what do you get? Well, you're going to get 4B minus 4B, which is B0. You're going to get negative 2C minus 2C, it will be negative 4C. And you're going to get negative 2 times 0 plus 1, which is going to be 1. Okay, so I get this. Now is it clear what A, B, C are? Now notice that I easily see that C is what? C is negative 1/4. I'm going to now do back substitution. C is negative 1/4. And then I'm going to plug that in the second equation, and I'm going to solve for B, and I'm just going to say this. So you have negative 1/4 here, and then plug in C in the second. You're going to solve for B. What do you get? What do you get? Negative 1/8. And then you're going to plug in the value of B there in the first equation. You get 1/8, right? The system of equations that I have here, these are called linear system of equations. When you go to differential equations, you'll see linear algebra, and they are going to talk about how to solve a system of linear equations in as many variables as you want, 50,000, whatever, as long as they are linear equations. But this is the most general algorithm you can apply to solve for A, B, and C. Of course, like I said, you could do other things, right? What you usually have done probably in pre-calc was what? You're going to get two equations in two elements, right? How you're going to do that? Well, from the second equation, for example, you can solve for C or B, whichever you want. Let's say you're going to solve for C, or let's just say the following. From the first equation, you solve for A. You're going to get negative B. So plug that in here. Then you're going to get two equations in C and B, and then you know how to handle that. Two equations in C and B. Okay, so you could do that. You could do that as well. But the way I did it, I can actually write a program in a programming language, instruct it to do the steps that I did. I can make an algorithm, and it can follow that. Okay, so that's like a general algorithm. In any case, so let's now conclude what we found. We started with the fraction 1 over x minus 2 times x squared plus 4, which is a over, we said a over x minus 2 plus bx plus c over x squared plus 4. Now, what did we find? We're going to plug in what we found for A, B, and C, right? So if I do that, A is 1/8, B is negative 1/8, and C is negative 1/4. Okay? And now you can simplify that, okay? This would be 1 over 8 times x minus 2. This would be negative, this would be negative x plus 2 divided by x squared plus 4. Actually, I have to say times 8 here. Okay. All right. So now you're going to integrate that, right? So you're going to integrate 1 over x minus 2. Is everybody okay with the algebra that I did in the previous step? You guys are okay with that? If you factor out negative 1/8, you're going to get x minus 2 here, right? Sorry, you're going to get, if you factor out negative 1/8, you're going to get x plus 2. And then negative 1/8 is right here. Okay, so this would be 1/8 integral of 1 over x minus 2 dx minus 1/8 integral of x plus 2 over x squared plus 4. Right? Any questions? No? Okay, and finally I get 1/8. This would be ln of absolute x minus 2. The second one I actually have to break it up. Oh, why am I saying plus? I have to break it up into 2, so I'm going to get x over x squared plus 4 dx minus 1/8 of 2 over x squared plus 4 dx. And I guess you can factor out that 2, and you're going to get 1/4. So this would be 1/8 minus, what would be the integral in the second? We did it a few minutes ago, right? Yeah, it'll be the integral would be half ln of x squared plus 4. You have to do a substitution by taking u to be the denominator. And the last one, you get 2 over 8, so that will be 1/4. And then you end up with the integral of 4 plus 1 over 4 plus x squared. And that is, has to do 1 over root of 4, right? So it'll be half tangent inverse of what? X over 2. And I have to say a plus c at the end. Did that make sense? Any questions at all? Any questions? Okay, the only way you get better at it is by practicing a couple of times. Okay, if you don't practice, you may not be able to finish it in the exam. Now, I want to make a remark here, though. We solved for A, B, and C, but I want to make one remark here. We could have, so going back to the line here, let me highlight that line. So we obtained this line here. I could have figured out what is A very easily. How? Remember I said this equation is true for any x, so I can plug in. So let me say, this is just a side note, okay? So you're plugging in. If I plug in x equals to 2, if I plug in x equals to 2, the second term vanishes, right? So if I plug in x equals to 2, this guy vanishes. So you get x equals to 2 here, so that's going to be 4 plus 4. So it will be 8a. So on the left-hand side, you get 1. On the right-hand side, you get 8a, right? When you plug in 2. You agree? When you plug in 2 for x, on the right-hand side, you get 8a. On the left-hand side, you get 1, because the second term will vanish. Everybody's okay? So then I right away get a to be 1/8. Is everybody okay with that? So once you get a to be 1/8, you can plug that in if you want, and then you want to figure out what should be B and C. Is that making sense? Now, another thing you could do here, you see that x squared plus 4. How can you make that 0? plug in, how can you make x squared plus 4 0? Well, it's not going to happen with real numbers, so well, you can plug in what? You can, if you feel comfortable at working with complex numbers, you can plug in 2i. That would imply that x squared would be exactly, what is 4i squared? If you square 2i, you get what? You get 4i squared. But what is I squared? -1, so you get -4, right? So if you plug that in, the first term will vanish. So on the left hand side you still get 1. On the right hand side the first term vanishes. When you plug in 2i, you get 2i times b plus c. That would be multiplied by 2i minus 2. Okay? And so what should you do? Well, you're going to multiply out everything on the right hand side. So if you do that, what are you going to get? Let's see. You are going to get negative 2c for sure, and negative 2i be negative 4b. That's something you're going to get. And then you're going to get negative 4b, negative 4bi, and then you're going to get plus 2ci. Right? Am I making sense? So you're going to collect the I terms and the without the I terms. So from there, what do you get? You'll get that a negative 2c minus 4b. That's the real part, right? That's the real number. It doesn't have any I. So that real number would be the left-hand side 1. On the left-hand side, I can say that the coefficient of I is 0. So then you can say this is negative 4b plus 2c is equal to 0. Am I making sense? And then you have two equations to unknown. You know how to find b and c, right? I'm not going to go carry that over. How in this case, plugging in 2i didn't really give us much advantage. I mean, it's still quite a bit of work. But sometimes when you plug that in, you might be able to avoid more work. Okay, but you can plug in 2i in order to make things 0, the way we make things 0 by plugging in 2 or something. Okay. Is everybody okay? So that's another way, plug in values of x. So it doesn't have to be, I can plug in any value of x I want to. Okay? So you plug in suitable values and try to see if it gives you any advantage. But at the least, when you plug in x equals to 2, you right away get a. And once you know a right away, then when you have this set up here, if you already know what a is, right, you right away know what b is. And if you know A and B, then you know what C is right away. Am I making sense? You didn't have to go through all this work that I did here. If right away, remember I know what A is. So let's not do any of the work here. Okay? I suggest you do the following. You find A right away by plugging in 2, and then you set up this system here, right? You know A, you can find B. If you know B, you can find C, and then you're done, right? You don't have to go through any of the work that I did. Am I making sense? There are too many things that there are a couple of different things I could do, and I'm not going to write down all of those, but I'm telling you there are many ways you can go and pick the most convenient one. Okay? But you should know the general way. All right, so that's that problem. Boy, that was a long problem, wasn't it? Or maybe I'm talking too much. All right. Let's see if I 5 minutes. So let me try to find a problem that can be done in 5 minutes. something that I haven't done in the other section. Okay, so let's say I have the integral 1 over 1 plus e to the x dx. You look at this integral, do you have any idea right away how it's going to work out? You think you know how the steps are going to work out at the end? I mean, in many of the integrals, we have enough experience to see that, okay, this substitution is going to work out, or this is going to work out. But this one, you really don't really have that type of intuition. And, well, I mean, when you don't have an intuition, just try out stuff. Okay? So the most, I cannot think of any person who wouldn't try this at some point. Right? You will take u to be 1 over 1 plus e to the x and see what that leads you to, okay? Well, okay, so then from this, I can find du, and du would be what? E to the x dx. Are we okay with that? I am in a little bit of trouble here because so I can replace the integrand now by 1 over u, but then in order to transform dx to du, I need a factor of e to the x. I don't have a factor of e to the x in the integrand, right? So that's the problem that I have. However, notice that from the equation for u, I can say u minus 1 is e to the x. Okay, so then I could say, well, du would be u minus 1 dx, right? Well, furthermore, I can say that 1 over u minus 1 du is dx. So now I know exactly how to write dx entirely in terms of u. So this is this is not an ordinary integral that we have seen before. We had to do a little bit of work at the beginning. So now notice what's going to happen to the integral. So this integral that I have, this would be 1 over u, and then what is dx? Dx is 1 over u minus 1 du, right? So what's the integral that I end up with? 1 over u minus 1 times u, right? How would you find that integral? Well, this is a rational function in u. Rational function in u. So now you know that the denominator is already factored out. The decomposition of this fraction would be what? A over u minus 1 plus b over u, right? And you can actually check that, this should not be pretty bad, because I'm going to guess that a is 1 and I'm going to guess b is 1. Let me see. U minus u plus... No, I'm going to assume that b is negative 1. I think it works out. Okay? And so, after using the decomposition, then you see that you end up with ln of u minus 1, ln of u, and then I have to go back to my to x, which is what? U is e to the x? Sorry, e to the x plus 1. Okay, so this would be this would be e to the x minus ln of e to the x plus 1, is it? Plus the c. In fact, I do not need the absolute value, so all I get is ln of e to the x minus ln of e to the x plus 1. What's the first thing here? This is just x, right? Okay, I'm going to just stop here. You should try to finish up 7.5 as soon as you can. I send you most of the solutions. You should not cheat, okay? You should not just look at the solutions before you try, okay? Try it at least for 10 minutes for each problem. If you're still stuck, then look at the solution for hints, okay? Then do it.
Right side of us.
What's your how many absences?
None. And I have an A. Thanks.
Your pen.
Your pen.
Absences?
0. I have an
What's your grade?
A. I have an A on the first exam.
That's what WebAssembly tells you?
Yes.
Okay.
Yeah, I just looked.
Okay. All right.
Thank you.
What's your absences?
0.
Grade?
B. And tomorrow or Friday. Friday.
You can just watch the videos and finish up stuff.
Yeah, I think so.
Just look for homeworks on WebAssign and
Will any of them be due before like Saturday night? Because we won't be back until Sunday sometime.
probably not till Sunday.
Thank you. Thanks.
Thank you.
Interconnect problems. There was like 3 problems and I did all of them right, but one was like the wrong because of the simplification.
Did you send me an email?
I didn't. No.
Why don't you send me an email and then I'm
See it?
to change your score, okay?
Okay.
If you have enough work there, I'm going to
I'll
change
just-
it. Okay?
okay.
Send me an email.
Right.
Otherwise, I won't remember.
Okay.
Okay? Yep. I thought it said 210.
But it,
Is it? The seminar, does it say 210? I thought it said 210. That's why I'm. Is it 210? Yeah. Okay. No, I had a class there. That's why I was staying there. I thought it is there, but I was wrong. There is no class there right now. I don't know why we didn't just make it there.
Exactly. You should have started off late.
Chris has a class on that.
Yeah, but not on Wednesday.
Is it Tuesday, Thursday? Unauthorized.
Yeah.
Yesterday, I got work from work. 7:30
The cable here is different.
I noticed that a lot of them have some wings bent inside.
Yeah.
Like this is
A lot of them. But sometimes that actually makes things color changes or something. Someday I think they should change them to HDMIs because all the new computers, they don't have VGAs anymore. They should think about changing them.
well, fat chance.
Right. Well, the color is fine.